A smart home is a good example of a distributed computing system where several computers communicate in order to coordinate the activities of the overall system. Distributed systems are particularly useful in an example like a smart home where the actual devices need to be physically distributed around the house. In this example, we'll use two computing nodes, a console here and a sensor node here. A smart home uses network computers to help the occupants of the house manage all the actions of the various devices in the house: appliances, entertainment devices, convenience devices. Our system will have two nodes: a door sensor that tells when a given door is open or closed, and a console that allows someone to interact with the smart home. MQTT is a publish-subscribe service for distributed systems. A broker manages the communication of messages between the various devices in the distributed system. A device can subscribe to a given topic. Then, when a device sends a message on that topic, it goes to the broker and then on to any and all devices that subscribe to that topic. Here's a UML sequence diagram for the operation of our smart home. Both the door sensor and the console connect to the broker so that the broker knows they're interested in messages relating to this system. The console then subscribes to a topic relating to the door. When the door opens, it sends a message to the broker and then on to the console. This is code from the door sensor. It uses a Hall effect sensor which reacts to the presence or absence of a magnet which relates to whether the door is open. We read the Hall effect here. We also write it out to the LED on the board, largely for debugging. If the sensor value is changed, we send a message starting with the topic and then the value of the sensor, and then we end the message. This code is from the console. The onMQTT message function is called whenever the console receives a message on a topic to which it has subscribed. It parses out the topic name and then the value contained in the message. It looks at the topic name to determine how to process the message. In this case, it can handle messages relating to two different doors. And in this case, it simply prints out the sensor value. Now let's take a look at this system in operation. Here's the door sensor node with the Arduino and the Hall effect sensor circuit. We have the Hall effect sensor device and a pull-up resistor. When I move the magnet near the Hall effect sensor, the LED goes on to indicate that the door is closed. When I remove it, the LED goes off. The Arduino is also sending messages on this topic to the MQTT broker. Meanwhile, the console is listening for messages on this topic, and as it receives messages, we see them on the serial port. MQTT's message facility allows more abstract communication between devices which may operate with different hardware and software. And its brokering facility makes it easier to add and delete devices from the overall network. Thanks for watching.